So here we want to find the zeros of this polynomial x cubed plus 2x squared plus 5x plus 4. Using Descartes' rule of signs, we see there's no sign change with f of x. So that means there are no positive zeros. Now let's find f of negative x. We see f of negative x, only the odd powers become negative. So we have negative x cubed plus 2x squared minus 5x plus 4. And you notice we have how many sign changes? Well, here's one, here's another one, and here's another one. So there are 3 sign changes. So we're going to have 3 or 1 negative 0. The next thing we're going to do is use the rational zero theorem. We could use that because we have integer coefficients. The rational zero theorem applies to integer coefficients. So we look at the factors of 4. So factors of 4 are plus or minus 4, plus or minus 2, and plus or minus 1. And then we look at the factors of the lead coefficient 1. The factors of 1 are plus or minus 1. So possible rational zeros are the ratio of these factors to these factors. So we'll have 4 over 1, so we have plus or minus 4. And 2 over 1, so that's plus or minus 2. And 1 over 1, so that's plus or minus 1. So we have 6 potential zeros here, but we're told we have no positive zeros. And we have either 3 negative zeros or 1 negative 0. Thus our possible zeros are going to be negative 4, negative 2, or negative 1, because there are no positive zeros. And we either have 3 or 1. So maybe all 3 of these are zeros of this function, or maybe just one of them. If one of them is a zero of this function and the others aren't, then most likely we have 2 imaginary zeros, because we have to have 3 at most. So the way to figure out which one is a zero is do synthetic division for each of these, and then you end up with a remainder of 0, if it is indeed a 0. So let's do that. So we see the possible zeros are negative 4, negative 2, negative 1. So we're going to do synthetic division. And so I have my polynomial here, and I've taken the coefficients 1, 2, 5, and 4 down. I'm going to try, I normally try the smallest absolute value here, which would be negative 1 first. So that makes it easier. So let's try that to see if that goes into here without any remainder. So I bring down this 1, and then I multiply these two. So negative 1 times 1 gives me negative 1. And then I add these two. 2 minus 1 gives me 1. And negative 1 times 1 gives me negative 1. Add these two. 5 minus 1 is 4. And negative 1 times 4 is minus 4. And I add these two to get 0. And this is my remainder. So since 0 is the remainder, that means negative 1 is a 0. And since negative 1 is a 0, that means x plus 1 is a factor. X minus the 0 is a factor of this polynomial. And what do we have left then? That means we have this x plus 1 divides into this polynomial with no remainder. And how many times does it go into this polynomial? Well, it goes into this time, this amount of times. And what does this stand for? It's 1, 1, and 4. Well, the 1, 1, and 4 stands for 1x squared plus 1x plus 4. Because we reduced this degree by 1. So what we're left with now is another polynomial, x squared plus x plus 4. And we want to know what are the zeros of this polynomial now. So in other words, we want to solve this equation here. Now luckily this is a quadratic equation, and now we could use the quadratic formula to find the zeros of this polynomial. So let's recap what we just found. We found that negative 1 was a 0 of this polynomial, and when we divided negative 1 into this synthetically, in other words, we divided the polynomial by x plus 1, by this x plus 1. There was no remainder, and we found that we got out x squared plus x plus 4. So in other words, x cubed plus 2x squared plus 5x plus 4 can be broken down into x plus 1 times x squared plus x plus 4. Now we want to break down this quadratic polynomial a little bit further. And the way to do that is we can find the zeros of this quadratic polynomial using the quadratic formula. So let's do that. So the quadratic formula says the solution to this quadratic polynomial, the zeros of this quadratic polynomial, are given by negative b plus or minus the square root of b squared minus 4ac over 2a. And in this quadratic polynomial, a is 1, b is 1, c is 4. So let's plug that into our formula. So we have x equals negative 1, negative b, plus or minus the square root of b squared, 1 squared, minus 4 times a, which is 1, times c, which is 4. So 4 times 1 times 4, divided by 2 times a, 2 times 1. So 1 squared minus 16 is going to give us negative 15 here. So simplify this is negative 1 plus or minus the square root of negative 15 over 2. Now the square root of negative 15 is an imaginary number. So we can replace the square root of the negative here with I. So what we end up with is negative 1 plus or minus the square root of 15i over 2. So there are our two imaginary zeros. So what are our zeros? Well, our zeros are negative 1 is one of the zeros, and the other two zeros are negative 1 plus root 15i over 2 and negative 1 minus root 15i over 2. So these are the three zeros of our polynomial x cubed plus 2x squared plus 5x plus 4, and we have one real zero and these two imaginary zeros.